Hello, Caritam. Good afternoon. Good afternoon. Okay, so I still have to do one chore, and then I can start the stream. Hey X2, hello. Oh god, this freaking out of, oh god. No, that's worse. That's my auto formatter running. Oh no, undo. So I have one chore to do before I can start the stream. That chore requires me to edit some HTML files, but I still have my LSP enabled. That is not a good idea. LSP stop. Jesus Christ. I was about to bork the entire Zig website. Oh, man. So I'm editing the Zig website. That's what's going on. Just taking a moment to do it. Okay. I'm done with the chore. Okay. Oh, slow day. So let's see how it's going. Oh, people on YouTube. Let's see. Hello. Can I use Zig to build microservices? If not, what language is best, do you think? Oh, God. To build microservices. Well, technically, one of the reasons why the microservices approach became popular is that it allowed you. Well, no, to be clear, it became popular because of marketing. It's entirely a marketing thing. But at least one of the stated benefits of microservices is that it allows you to use different languages per microservice, because the idea is that every microservice is a thing in its own. Sorry, a thing on its own, and so different teams can work on different microservices written in whatever language they want, and it doesn't matter much the fact that these are different languages, because they still communicate through HTTP or gRPC or Kafka topics, so some kind of message bus one way or another. It's either gRPC, HTTP, like REST, GraphQL maybe, I don't know, or a message bus. So from that perspective, yeah, you can do whatever you want. That said, is Zig a particularly good language in that ecosystem? I would say, like today, the web ecosystem in Zig is not super complete. we're just getting started, so you can pull it off if you want, for sure. Is it like, I don't know, you're the best production ready strategy, like just boom, kill the problem right away with like are you gonna get a developer experience that's gonna be dramatically better than other existing offers? I wouldn't say that. So let me go to the main view and let me show you this. Zig Zap. So if you go to the Zig Zap organization on GitHub/Zap, or just search for Zig Zap, you will find that there is a web server implementation written in Zig that it's good enough to be even exposed to the internet. So this is one way of making it communicate with other things, or in general build a backend service. Of course, Zig has gRPC support, I think. So let's see, Zig gRPC. I think somebody must have done the work to make this stuff work together. In any case, you can find if these libraries, you can find and try out these libraries, see if they work well enough for you, and so you can totally pull it off. I would not say that this is something that you should do because you expect to have a superior experience than with other languages. You can do this if you want to try out Zig, take it for a spin, see how it feels. I will tell you that this is not the type of thing that today is made super easy by using Zig. Today you will have a better time trying to do embedded development with Zig, or trying to do a native application, a game, for example. There you will already today feel the improvements that Zig makes over alternatives. Web dev stuff, not so much. It will get better, but today not yet. What's the best language to build an authentication service? The best language is kind of a tough question because it boils down to opinion. But the ones that you mentioned are okay: Java, Go, Node. Of those three, I would personally prefer Go over the other two. But if you know JavaScript and you like JavaScript, Node is decent. If you want to go for something fancier, you could try Elixir, for example. With Elixir, you get a very interesting ecosystem because of the OTP. So go try that. That would be my recommendation. Okay, man, I'm sweating. It's super hot in here, and I think I need to drink some caffeine. I'm curious what you think is needed for Zig to be better for web dev. Okay, I hold that thought. I'll answer your question in 30 seconds as soon as I come back with something cold to drink. Okay, I'm back with a can of Coke. Oof. So what do you think is needed for Zig to be better for web dev? TLDR, long story short, people just need to build the ecosystem up. I really just think that most of this stuff is, how can I say? It's not all that hard. It's just that somebody has to do it. And normally when you want to do web dev, you don't want to have to implement everything yourself from scratch. Like, normally you don't want to have to build an HTTP parser or an HTTP server, right? You expect that stuff to be already done. You kind of think it's not your concern. Like, it shouldn't be up to you to write that stuff. which is a perspective that, well, that's what everybody thinks 99.999% of the time. So I don't need to justify this perspective. It's already the most wildly used one. But if you stop to think about it, it is a funky perspective occasionally to some degree. Because if your job is to make a web thing work, then yeah, maybe it makes sense for you to not want to write your own HTTP server. But it's not like it's something that is entirely out of your hands. It should still be at least somewhat one of the things that you should be able to have an opinion about, be able to tinker with. In any case, setting that aside, the HTTP server is maybe like a bit of an extreme example, but the same applies to, I don't know, like a JWT library, JSON parsing, coding, decoding, serialization, deserialization, templating languages. There are, by the way, some implementation of these things in the Zig ecosystem. So you will find there's a JSON parser in the Zig standard library, and you will find libraries that implement templating. I'm implementing a templating library, although the fact that I'm still implementing it means that it's not yet ready to use. So I guess that's also an example of some parts of the ecosystem not being quite there just yet. Yeah, it's way worse than Golang, for example, the ecosystem, I mean. Oh yeah, absolutely. Yeah. So for example, if we compare it with a ecosystem that it's like full-fledged for a language that you could even almost argue is entirely dedicated to doing this kind of work, namely Go. Like Go, at the end of the day, is a language that is designed to solve these kind of problems. Backend services, more or less. It can be used for more than that, and it is used for more than that. But ultimately, that's like its bread and butter. Like the Golang HTTP server, it's, man, pretty nice, right? All this stuff. So that's where it shines. Zig is not that language. It's not there yet. The question then becomes, okay, can Zig get a kick-ass ecosystem off the ground and be competitive with Go, for example? I would say, generally speaking, yes. You do still have the question of, do you really want to pull in all the power and all the potential issues that you can get from a systems level programming language like Zig? Because with Go, what you get out of Go is that you're not going to have view B in your web server. With Zig, if you try to, get fancy and you make a mistake and you have a dangling pointer, then you're going to have UB. How willing are you to risk that? And the reality is that most of the times websites don't deserve that level of care. Like you just want to have a web service kind of work well enough, and you don't even want it to be perfect. So that's not going to change. So I would say that Zig is not going to be the best tool for web dev all the time. There's a lot of web dev that really is not meant to be perfect software. And in turn, so it's not gonna be something that you want to put the effort into, that you would have to craft the best Zig implementation of it, something that you couldn't ever pull off with Go. You don't ever want to, almost never want to go there. So no pun intended, sorry. and so Go is still gonna be relevant. On the flip side though, man, I do occasionally go back to Go for web dev stuff, but it is painful. It is painful going back to Go from Zig. Worse error handling, automagic stuff. That I particularly hate the error handling. Not that I think that the error handling in Go is inherently bad, like in an absolute sense. I still think that what Go does is superior to exceptions, for example. But it is worse than what Zig can do. Like they don't have try, for example. They don't have try. They don't have error defer. They don't have. They don't even have options, right? Go doesn't have optionals. So like if something is a pointer, it's on you to check if it's nullable or not. Am I wrong about this? It's as you can tell, it's been a while since I've done some non-superficial Go development. Another thing that I don't like about Go is how, and this is changing, to be fair, this is changing now, but another thing that I don't like about Go is that since you cannot talk in terms of types as values, like in Go code, you cannot pass around a type, like a struct definition as a value around, then you have all these libraries that kind of want to obtain type information from you, and then you have to pass them an empty instance of that type, or like a pointer of that type. And because since you can't just say, please, like a JSON parser, you can't say to a Go JSON parser, please deserialize this JSON into this struct type. No, you have to give it an instance of the struct type, because that's the only way the thing is able to obtain from you what kind of type you want to deserialize your JSON into. It's super silly. So I would say the Golang has an advantage, or I guess it has two advantages, right? One is potentially temporary, which is the better ecosystem. We can get a comparable ecosystem going in the Z community, but the second advantage is that, well, it's a higher level programming language, so you trade your ability to create the perfect program for avoiding the worst outcome UB. And that makes sense most of the time, because web servers just most of the time don't require or deserve, or like it's just unfeasible for you to aim for perfection. You just want to aim for good enough, economically speaking, basically. But when you do, or if you want to have a better programming experience, so like you're not doing anything that is super giga critical, and you're confident in your ability to write Zig enough to not do terrible mistakes all the time, so ultimately you will too get something that works, and you will have a better programming experience if you appreciate Zig features over Go's ones. Like for example, Go's defer not being lexically scoped. It's super weird. Go does have nil, no? Yeah, it does. But optional stuff is not about having nil or not having nil. Optional stuff is about having pointers that cannot be nil. And I don't think the pointers cannot be nil in Go. I believe they can. Or rather, I am sure that pointers can be nil, but I think that is a property of normal pointers. You don't have to make them optional pointers. Yeah, I think that you still have nil problems with Go. What a terrible mistake that the creators made there. Holy shit. By the way, Crypto, I saw your issue on the Zing repository. It's hilarious. People were asking, I think yesterday, or like in general, people occasionally ask, like, what are you guys gonna do once you get rid of LLVM? Because getting rid of LLVM means that like you lose optimizations, and like you're never gonna be able to do better than what LLVM does. And then I saw your issue, which cracks me up. Who knows where it went now? I guess I can search for one that has you as the author. That's not your nickname, is it? Oh, it is. Let's go. Check it out. That cracks me up. So, apparently, printing large integers causes significant slowdown of compilation and runtime performance under LLVM. So apparently the allegedly optimized version takes around 10 seconds to print a big number at runtime. printing the number using the native backend is near instant. Imagine. That's hilarious. I think I'm gonna mention this issue occasionally when this type of topic comes up. Oh man. Okay, so what do we want to do? What we want to do is take a look at our HTML parser and improve it. So I think that we left off with this knowledge that our tokenizer still sends to the AST text nodes that are entirely made up of spaces. And we don't want that. We want the tokenizer to avoid spaces. And we also, I think, realized at some point that we were doing some math wrong. I don't remember precisely, but I remember with confidence that somewhere I'm doing some index math that works off of wrong assumptions. Or rather, assumptions are like right most of the time, just not all the time. So like it's not completely random, it's just not always right. Let's take a look at what we're doing here. So one thing that I understand, and if I remember correctly, one thing that I remember really well that I'm not accounting for is trimming suffixes from text tokens, like trimming basically spaces as a suffix. I do in theory trim the any white space prefix. I just don't do it for suffixes. But in any case, this is not a space suffix. This is like space only. We need to understand what's going on here because something is going wrong. That is for sure. As you can see, there's a bunch of those examples and they're all wrong. What is this live stream about? As the title says, I am working on a HTML language server implementation. And as part of that work, I'm working on an HTML parser. And now I am working on the logic that tokenizes and parses as in and then puts inside the AST text nodes. And right now I'm grappling with white space related problems. So let's take a look once more at how these things work, how this thing works. So we consume one character. We don't have to worry right now about what's going on in here because it's fine. This branch is only in the case that we cannot consume a token. So right now, that's not something that interests us much. So we did find a character. And if the character is a lower than, then we start thinking that's a tag, and that's fine. If it's a null byte, I guess it resets. Like this null byte handling probably will need to change. So here's where the core thing is. Basically, when we switched to a text state, which happens here, so we are in the initial state where we don't know yet what we're gonna find, and we find a letter that isn't the beginning of a tag, we assume that we're looking at some random text that's somewhere in the HTML. So we move to the text state and we start from the character that we just found, which is at idx.1, because when we find a character, we move idx past it, so -1 is current character, basically. Okay, so this is fine. The thing is, we want to continue. We start with white space only set to true. Do we do that? Yeah, we start by assuming that what we found is only white space. Unfortunately, that makes us not evaluate the original one. So let's do it like this. Okay, we do check also the first character that we find, because it could be a space, maybe. Okay. So that sets the stage correctly. Then, as we keep finding characters, we say, wait, are we still in white space only? Have we only seen white space up until now? If so, then we want to move the start forward, because we want to skip everything and then we said white space only to... Oh, we don't negate this anymore, do we? We don't negate this. We set it to is white space, and then when this... Okay, I think I solved where the... I renamed that variable. It had a different name earlier, so that's probably one reason why. Okay, let's see what happened. So expected this output, got this output. So what's happening here, this seems okay. This is much better. This is now more in line. So here's what's happening. Basically, I have logic that decides whether these spans should be broken up to go on a new line or not. And the logic is a little bit funky. So the rendering, basically, I think the tokenizing now happens correctly, but the rendering at this point is making bad choices compared to what we want to, well, have it do. So we need to reevaluate how we decide whether things should stay on a single line or whether they should be reformatted to be vertical, which, to be clear, that means that my formatter makes decisions. Like if we had head and then meta, and then head, instead of being on a new line, was closed here to the right of meta, the auto formatter would move that thing below on a new line to have this thing happen. Now here, that's kind of what's going on, except we're being inconsistent with regards to choosing to align things vertically versus keep them horizontal. We are printing tags thinking that they should be vertically aligned, but then for this text we don't think it should go on its own line. That's what's happening. So that's what we need to fix. Let's see. Ades JG. Hello, I have some questions about the syntax around for loops. I really like the 1.5, but there should be 2 more options: to include the last 5 and to be able to count down. In Zig, those ranges are purposely extremely basic and simple, and they're not meant to be a more general purpose type of range type that you can do more stuff with. So long story short, those are features that are reasonable to want to have. They would make the range language construct more complex and featureful than what the authors currently want it to be. And in general, the Zig philosophy is use for only for extremely basic looping. And in that definition of extremely basic is also included the concept of not iterating backwards. So not iterating from 5 to 1, but only iterating from upwards from 1 to 5. And use while loops for everything else. So if you want to loop downwards, you're expected to use a while loop. So use a while loop, and in the while step, the continue step, the continue expression, sorry, you decrement your counter. And as for being having the range be inclusive, this is just not supported. And this is also true when it comes to slices. I think that in a sense, I don't know how factually true this is, and I don't mean to say that necessarily there's a strongly willed design philosophy behind what I'm about to say, but it seems to me that basically for loop ranges, their syntax and their capabilities tend to mirror what you can do with arrays. And when you're doing slicing syntax, and when you're slicing an array, you don't have a syntax to slice an inclusive range. So it's on you to do +1 if you also want to include the one item more. So it is what it is. That's how it works. Up to you to decide if you like it or not. Keep in mind though that the perspective of saying, well, I encountered this use case where this thing would have saved me 5 lines of code and it would be nice to have, does have some weight to it. It does make some sense. But at the same time, beware that if every time that happened, every time somebody had a use case where having one extra little bit of feature in the language would have saved them from writing 5 lines of code, if all of these people got it their way, then Zig would be C++. That there's a language that already does this, and C++. And then you have people who just don't want to, they just don't like C++. So keep that in mind. It is annoying because sometimes you just will to be able to do one thing, but then it's annoying. I just think the code becomes a bit weird. For example, 1 5 + 1. Well, if you if you're just doing well with a variable, yeah, it would be +1. I don't find it weird. So from my perspective, the reason why I don't find it weird is because when I'm looking at a for loop with a range, I am imagining that it's iterating on a sequence, and how can I say? Looping on a range that is on an open range is what you normally do when iterating arrays. And so my programmer brain is pattern matching it against that. I get it, by the way. I totally get it that sometimes it's a little bit awkward, but I don't know. It's just a matter of getting used to it. So, well, I don't know. This is it. This is how it works in Zigland. Christopher IT, hi. Do we have any chance to see lambdas in Zig? Well, here's a question. Here's a counter question for you. When you say lambdas, do you also expect the ability to do closures? So, you know what? I'm curious to see your answer. So by closures, I mean the ability to reference variables defined in the outer scope, defined in the scope where you are defining your lambda function. Because that is a different thing. The ability to close over values is different than the ability to write anonymous functions, which are usually also can be colloquially called lambdas. That said, some people, when they say lambda, they tend to imply the closure aspect. Some other people don't. That said, what I can tell you is that no, closures are almost certainly not going to be in Zig, because in a systems level programming language, closures are foot gunny. They make it easy for you to pass around dangling pointers inadvertently, and they tend to encourage a programming style that does things with memory that might not be optimal. this second statement is like, it's my perspective. I don't have any hard evidence to present to this court to really, to really prove scientifically my statement. Is just how I kind of perceive those kind of things. Like, very oftentimes you pass around lambdas with a closure because it's a cheap way for you to, have a data pointer, have some extra state, because the API doesn't offer you another way of doing it. But you always have alternative ways. And I would even argue that probably in many cases, you end up with a better API, period. So closing over values, problematic for a language like Zig. Could be done. It's just like a foot gun fest. Anonymous function declarations, like declaring a function on the fly, it used to be an accepted proposal, and it almost got in the language. But then both who proposed it originally and some other people involved in part of the Zig core team kind of wanted to walk back that decision. I forget the number. Maybe it was 14. Was it 1414? I think it was 14 something. Let's see. 1717. Oh, I almost remembered correctly. Make function definition expressions. So that's what it would look like. Or rather, let's start by looking at this. So here, this would be an example of a function declared on the fly, and the implication of having that ability would be that then we would be able, and probably the language would change entirely to allowing only this style of the function declaration. So instead of having, pub function syntax, pub function name syntax, you would have pub const name equals function. So basically all functions would be anonymous, and then they gain a name by being bound to a decal. Kind of like structs work in Zig, right? In Zig, all structs, like a struct definition doesn't have a name, you give it a name by binding it to a decal. So there's that. 6965, I imagine, is the one from specs, right? It's the macro one from specs. Let's see, 6965. Yeah, so stack capturing macro. This is, I don't even remember all the details, but this is like super advanced stuff. Yeah, this is still open. I would say this is like, well, 6965, so you can check it out if you want. It's a bit peculiar. Honestly, if the previous ones didn't pass, there are very low chances that this one will pass. But to be fair, this is also more interesting because it's not just like, a little bit of syntax sugar like this or like that. For example, string NICU, you already pointed it out correctly. Yeah, you can declare functions in a nested scope. You just have this awkward syntax right now. I would say that in general, I think the general point is that Zig doesn't really want you to declare functions inside of nested scopes all that much. And that's why it doesn't want to give you easy syntax for it. That is my gut feeling. Obviously, that is, let's assume that I'm right. That's a reflection of what the core team and the people working on the language are going for. Comes with trade-offs, obviously. Being able to declare anonymous functions easily is expressive power, so it's nice, but it does tend to guide you towards a certain style of API design, composition, and abstraction, and it is true that oftentimes you are tempted to express something as in a way that basically the user provides you with a callback, but some other times that's not great for a few reasons, maybe also performance. So yeah, I don't know. That's where things are. I would say in my experience, having written like a good amount of Zig, so I'm definitely not the person who wrote the most Zig out there, but I did write a good chunk of Zig over the the course of its existence. I almost never care about callbacks. And the one time I designed an API that expected a callback, I did it only because I was lazy to design something better. Like I on purpose realized as I was doing it, I said, oh man, I'm being lazy. I know how I could make this actually better, like genuinely a better API to use. But I was lazy and I said, you know what, fuck it, just accept a callback, and then we invoke the callback and call it a day. So I would say if it's a programming style that you're used to and your mind tends to go there very often, because in some ecosystems that's kind of what you're expected to do, and like it works well and the ecosystem plays around that style a lot, then my recommendation would be try purposely to think of alternative ways to do that in Zig, and like expand your mind a little bit. That doesn't mean necessarily my point is not that you should like abandon that way of doing things forever, right? Or that it is inherently wrong. It is not. It's just that it's not the only good way of doing things. For example, when I started programming in Zig, I also had a lot of OOP brain rot. And I remember seeing interfaces and class hierarchies everywhere when I was writing stuff. And then at some point I realized that, well, man, trying to force these things to be like some kind of hierarchy, like yields me no advantage at all. Like I know that on an abstract level, these things all are different incarnations of the same thing, but when looking at Zig, for example, memory layout becomes important. So maybe two things are like on paper the same thing, but by being significantly different mechanically, they shouldn't be unified in a language that cares about these details. I can give you like a concrete example. I was writing a Redis client. By the way, this Redis client has bit rotted probably dramatically. So, as I was writing this Redis client, at some point I wanted to introduce pre-implemented commands. Like you can send commands to Redis by just typing them on the fly, but sometimes it's nice to have these things to have your API not be stringly typed, right? Not have the API work off of just random strings. So I went on and implemented these commands, and they are all commands, right? So in a sense, you kind of feel like they should be the same thing, different implementations of the same thing. But in reality, like this command has need to instantiate an instance of this command. It needs to save two arguments, because the command is pfadd key and then a list of elements. But another one, let's see, pfcount, probably still kind of the same, pfmerge. I don't know, some other ones. Well, point being, like they have the fields that they need to save are different. Scard just adds one argument. There are some Redis commands that don't even accept arguments. So point being, they are different inside of them. And so in a language like Zig, that means that you should be careful when trying to unify them, because you need to have a mechanical reason to do so. So long story short, do try to change the way you program when you do Zig on purpose. Like deliberately try to practice that. And then you can reevaluate afterwards how much then you feel like you need a feature after you've done that. Let's see. It's easy to handwrite closures in Zig with some comp time. You just can't call them with plain function call syntax. This is a feature. Overloading syntax is bad and against the Zig ATM. I miss map filter in Zig. If that was possible somehow I wouldn't care about anything else lambdas are used for. I think the map filter are not a great fit for Zig. I I don't know. I like that style of doing things sometimes. For example, I like also like list comprehensions in Python, which are like funky syntax, but they give you basically that. They give you map and filter. But in Zig you kind of don't want to do that. Like you let me tell, like, I promise you, there you can build an appreciation for not going down that path. There is something to gain by not thinking in terms of map and filter. And so get used to it. Purposely get used to it. Purposely go into a, how can I say, go through the motions of writing things in a way that is a little bit less comfortable. Start appreciating what's good and bad about it. And I don't know. And then honestly, if you still really want it, then maybe it means that Zig isn't the language for you, which is totally fair. But it is problematic when you get used to one way of doing things and then you expect it to be done elsewhere, everywhere else in the same way. But to do it, let's see. Andrew even put a proposal in milestones, so this proposal got a chance to be accepted. 4170. Oh, I can tell you that Andrew has rejected so many things that he proposed himself, so the fact that he made it, it's not an indication of much. So let me just say this: proposal anonymous function literals with function signature inference. Oh, sorry. In this case, it's not a proposal. It's not even a proposal from Andrew. He put it in milestones. No, putting it in milestones and then like keep bumping up milestones, that's not particularly interesting. What's more interesting is tags like accepted. Like if you see that it has an accepted label, that means that, well, it should go in. It's not a promise. People like the Andrew and the core team are allowed to change their mind. So for example, the one before 1717 was accepted and then it lost the accepted label. But proposals that are accepted, you should expect to go to the language at some point. Let's see. Label accepted. What do we got here? Improve overflow operations. That's accepted. So this should be implemented sooner or later. Don't allow unused bits in packed unions. Ship even more of the compiler in source form. Simplify the pending handler function to be only one function. Remove formatted panics. Formally introduce a class of errors that can be automatically fixed. Remove anonymous struct types from the language. I think this is a bit of an internal thing, so yeah, don't worry about it much. I can write without it, it's just more typing. Yeah, in general, Zig is not a language where a little bit more typing. Zig as a language will not try to, how can I say? Let's just say that you're expected to type. When typing is needed, you're expected to type. What accepted proposals are you rating most of all? Custom backends. They're coming. They're actually being worked on. So it's not just a matter of implementing a proposal, but I'm really looking forward to being able to build very quickly, not needing LLVM when doing a build bug, i.e. debug build. After that, incremental. The incremental compilation is gonna basically mean instant rebuilds. Like no matter how big your project is, it's gonna be instant to rebuild it, assuming you made a tiny change. And after that, we're gonna get a basically compiler REPL, where the idea is that the REPL is not really meant for like executing Zig code that you paste in, but it's mostly going to be meant to be something like the REPL is going to be part of incremental compilation. Like part of the idea of incremental compilation is to keep the compiler on. So not just turn on the compiler, like not execute the compiler to do a build and then exit, but instead the compiler stays on, keeps stuff in memory even, and then there should be tooling like integration with the editor or LSP or whatever, so that, you know, file changes, Zig automatically rebuilds the project without, well, while staying on. And when the compiler is in that mode, it will have a REPL that will allow you to ask questions about the compilation process and get answers. And that's going to be the baseline for the real incarnation of the Zig language server. Right now we have ZLS, which is a community project that does a lot of very clever work to give you LSP functionality, but it's not the Zig compiler. ZLS doesn't fully implement comp time. And that's fine. It would be tough to do all that work. But more importantly, it's not necessary, because the Zig compiler itself will provide that kind of diagnostics once we have incremental and the REPL implemented. So that's what I'm mostly, honestly, more pumped up for. It's not language features. It's, you know, toolchain capabilities, basically, more than anything else. I think in terms of language features, we're pretty good. Like, sure, there could be, you know, more stuff, some stuff that could be added, changed, improved. Well, but all in all, I feel like a lot of things are already great from that perspective. And instead having, you know, man, imagine instant compilations, like instant. Everything is in an instant compilation in debug mode. That would be so cool. Like basically having, like we were talking about Go earlier. Go is a, you know, has good features, has bad aspects to it. But one great aspect of Go is that it compiles really fast. And the idea is to basically get a comparable experience in Zig. So I'm looking forward to that more than anything else. Do you know if the pipeline operator has ever been considered for Zig? No, Zig is not a kind of language. Zig is the kind of language where you break your expression in multiple variable assignments, and that's how you do it, and that's fine. There are implications there, by the way, like doing this. And you know what? I'll tell you one thing. So, let me see. Maybe I'm gonna open a new tab. hx expert.zig. Okay, we have an empty Zig file. Let's say that we want it's just for the purpose of showcasing something. You normally wouldn't want to do this, but let's say that we want to create an allocator, create an array list, and put some bytes inside of an array list and then print them, maybe. Or you know what? Maybe we want to or let's do it simpler. We're gonna duplicate a string. So we could, in theory, okay. Let's start from the beginning. Let's do hello world. Okay. Okay, so like super basic. Right. Okay. Hello world. Okay, we got hello world. Not super interesting. Now I'm gonna complicate it a little bit. I'm not gonna complicate it in a smart way. I'm gonna complicate it just to showcase something. But let's say that now we want to duplicate this string before printing it. So I'm gonna do this const. What you do normally in Zig is this var. Actually, let me think about it. Should I first show you the success case or the failure case? Let's show you the success case first. So var GPA impl is std dot heap dot general purpose allocator. There we go. And this needs to be a colon. Okay, and then const GPA equals GPA impl.allocator. And then we want to duplicate our string. So I'll say, const copy equals GPA.dupe. Original. And then we can put original here. I don't know. And then we print the copy, but we have to print it like this. Okay. One thing that we can do. So I'm missing a try. We need to also handle errors. To show you that I'm printing something different, here's what we can do. We can mutate copy. We can do copy, I don't know, 1 equals, instead of hello, says, I don't know, hollow world. I think that needs to be a byte. So okay, this is gonna say hollow world. Let's see. Well, there's gonna be compile errors, but once we fix them, expected arguments found 1. What do I need to do? I need to give you the type. Yeah. Okay. Okay, and it prints hollow world. Oops. It prints hollow world. Hollow world. Wow. Not super interesting. Also, small aside, why can I mutate this even though this is const? I can do this because this is a pointer. It's a pointer to actually, I don't know. Does dupe give me a pointer or a slice? What does it give me? It gives me a slice. Okay, so it's a slice of bytes. So I cannot reassign copy to some other value, but I can mutate, since it's a pointer, like a slice, it's a flat pointer. I can write through it. If I declare this to be const, so I will get a mutable slice from this function call. But if I assign it to a const variable, coercion will happen. Like you can always cast a mutable string to a immutable string, but then you lose the ability to write through it. So this is, as it is right now, it's a compile error, and it will say, look, you made this a constant slice, so you can't assign through it anymore. Fine. Okay, just to clarify this tiny point. Sorry, that was a small aside. But here's what I wanted to show you. Okay, so here, look at what's happening. We create a allocator instance. An allocator is a data structure that obtains a page from the OS. It obtains 4 kilobytes of memory from the OS. And then it manages it internally, because the OS doesn't deal with, it's a B2B type of thing. It's not a B2C. The OS doesn't want to concern itself with tiny allocations. It only wants to concern itself with bigger chunks of memory, namely pages, which usually are 4 kilobytes big. But then, if every time you try to allocate something from the OS, you get 4 kilobytes of memory, and then maybe you just want to allocate, I don't know, a number, a very tiny value, then you're gonna waste, right? Almost like, I don't know, try to allocate 1 byte, and then you have 3 kilobytes, 99 remaining, and that's a huge waste. So that's what your allocator does. Your allocator takes those 4 kilobytes, splits it up into slots so that you can put more things in it. And then when you free something, what your allocator does is mark internally that a given slot has been freed and can now be reused. So GPA impl holds all that state. It's a struct that has all these bookkeeping inside of it. Then by calling allocator, we generate an interface to it. So this is basically just a tiny struct with pointers to specific implementations of how to do this bookkeeping, because this is one type of allocator, but there are different types of allocators, all supported by Zig, and they all basically have different implementations, but they all conform to the same interface, and that's what allocator is. Like this call to allocator returns an allocator instance, which is defined in std.mem, and an allocator is like, it's a vtable basically. Okay, so it makes sense, right? This holds some state, then you need to extract an interface from it because of how the language works, and then you want to use it. Let me show you how to break this in a way that doesn't seem unreasonable. And it seems like we are taking away convenience from the programmer. But let's think about the implications. So this actually used to work in the past. You could do this in the past. You could do const GPA equals this. So now from a type, I'm gonna use this as a value and directly create an instance of it. Oh, and then, oh man, the language really doesn't help me. So I'm gonna have to put parentheses in here. Dot allocator. Okay, so basically I'm instead of assigning this expression to a variable, we are chaining, right? We are chaining everything. I like doing var GPA.allocator. We can do this. So since this is a type, okay, what I have here after the colon is a type. It's just like a fancy type because the GPA has complicated toggles that you can, it has settings that you can switch on and off depending on what you are trying to achieve from it. Let's make a type definition for it. So let's call it, I don't know, my GPA. Okay, that is just to simplify a little bit the syntax. Okay, so now this can be replaced by, well, I still need to do most of it though. Right, we didn't change much, so this transformation shouldn't seem too hard to follow along. But we can do more, right? We can do .allocator .dupe, right? We can do directly the dupe. So we even get copy. Now, let's see what happens when I compile this. It will complain. And it will say that it expected a pointer to a general purpose allocator, a pointer, a non-const pointer. So the fact that here doesn't say const, it means that it's a mutable pointer, and instead found a const pointer. So what's going on here? What's going on is that Zig is so bitchy about chaining expressions that temporary values created by chaining expressions are marked implicitly as const. So whenever you chain operations, you're basically doing this. Like you're chaining an operation, but then the compiler will still create the temporary variables. Like you just don't see them, but the compiler will still create the temporary values and then call one thing after the other. So it's just kind of syntax sugar at the end of the day. But what compilers usually do is do these intermediate allocations, well, these intermediate like values, it will mark them as mutable. So it will basically create them as like var temp1, var temp2, ideally. But Zig doesn't do that. Zig declares this as const. And it does that on purpose so that when you see chaining, you can be certain that there is no temporary state that is being mutated. Because this is what's happening, right? When doing this, we are mutating, like let's assume that this actually worked. If this worked, then it means that we would be mutating state inside this temporary value that then like gets lost. And it's maybe, you know, in this case, it's in the beginning, but in another chain of calls, it could be like in the middle or at some point through it. So Zig really wants to make it clear what it is being mutated and what's going on. And if something is being mutated, it's a var. Only var things can be mutated. Or, you know, if something is const and you use it to mutate, it's because this thing is a pointer. So ultimately, what I said about only var things can be mutated is correct. There's just the complication that pointers are a thing and they kind of allow you to mutate other things through them. So, yeah. So long story short, in Zig, these I don't know, counter chaining, opposite of chaining thing is by design. By design, the language wants you to use one line to define your allocator implementation, mark it var because that's what holds the state, and then on another line do other stuff. I don't know. I hope that made sense. I hope that I made clear exactly why it's forcing you to do this, what there is to gain. Obviously, it's one perspective. I do not intend to say that this is, the one true perspective to have when writing software. It's the only correct way. Absolutely not. But it is what Zig is going for, and it does have benefits when you're doing this type of programming. Forces you to write in a way that cannot become hard to read. Yeah, within reason, within limits. Obviously, there are some things that you can't. If the programmer wants to write bad shit, there's no way of stopping them. That's such is life. Otherwise, I wouldn't be able to program in Zig. But the language does put this type of perspective front and center, and that is interesting. And by the way, again, it makes sense for, a functional programming language like Lisp to not go for this at all, and it's fine. And that's, I guess, the good and bad of using Lisp or Prolog, for example, right? Just Zig is like a very, very opinionated, not just opinionated, it's not a random opinion. It's a perspective that really maps well to what you want to care about when doing systems programming. So it really embodies that perspective, truly. On a side note, yep. You have to explicitly designate a stack var. Yes, which it would still happen with expression chaining. It's just that it's just that the semantics of what happens as the expression chain gets executed would be a little bit obfuscated for the programmer. And in reality, the truth is that you normally don't think about it much. And also, you tend to expect that the two syntaxes should always be comparable, right? You kind of expect that every time you have, a bunch of assignments to intermediate values to then chain basically a bunch of computation and then obtain a final result, you would expect the two things to be always to be able to go from one to the other. And in a higher level programming language, that should totally be the case, in my opinion. But in a lower level programming language, it makes sense to make this thing a little bit more nuanced, because the ability to not hide state changes inside of a chain of calls is good. Okay, that's my TED talk. Zig makes you think about where the data actually is. Hell yeah. Does it hurt to use GPA.allocator everywhere? I don't believe it does. I think it's fine. I don't think you have to assign it anywhere else, because the point is, yes, it is a function call, but as you see, the function just collects a few values, and that's it. And those values, I think any optimizer is able to trivially realize that they never change. So even calling GPA.allocator in a bunch of places will still ultimately generate optimized code everywhere. Take what I just said with a grain of salt. I am not an expert on LLVM. My hunch is that it's gonna be always optimized. I might be wrong, and you might incur in the function call in the price of calling that function, which most definitely gonna be inlined in any case. So you might go through the pain you might have to pay the price for assigning a bunch of values in that case. But even then, it's basically nothing. So I wouldn't worry at all. Question to Loris: const versus immutable, like const pointer, blah, 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 where the pointer is locked, but the reference memory can still be changed. Wait, what is the question? This is... Okay, what you're describing is the state with Zig, right? So const means that you cannot change this value, so the pointer stored inside PTR cannot be changed. But the value pointed by that pointer... Oh, further down. Okay, awesome. Thank you. But the value pointed by that pointer can be mutated still. So I guess the thing is, if a chain value were a struct with a const pointer to mutable memory, would that not bypass that protection? If a chain value were a struct, yes, it would. You would be able to do that. Yes, because you would have a temporary value that, I don't know, like accesses that pointer, and then you mutate it. Yes, but I guess the point is, I think like the key understanding is you're not inadvertently producing temporary values that are going to be mutated by your chain of calls, and then you lose all handles to that temporary value completely after the expression is executed. In this case, if you have a pointer to something, it might not be the same pointer. Like it is obviously not guaranteed that you're going to have other handles to that data. But I would say pointers are like a different class of complexity than just things that pretty much only relate to the stack, which is the case, the type of thing that you have to worry about in this case. So, and in any case, it's not meant to be a perfect, thing where it's impossible to do the wrong thing at that point. Like as you can see, if you write Zig, you do realize that Zig is trying to give you, to guide you down a certain path, but it pretty much never forces your hand. As in, if you want to do unsafe stuff, you can do it. It's just not gonna be super idiomatic most of the time. That's kind of where Zig stops. So you're never gonna get the kind of guarantees that like Rust gives you with safe versus unsafe, but at the same time you're not gonna get the kind of problems where you're locked into a certain way of doing things, and then your only escape hatch is to open an unsafe block, and now you're like in Fallout. Like you came out of your Fallout bunker, and it's like now you're in the wasteland. Your radioactivity meter starts to tick. That kind of thing. Thank you. It was a very good explanation. Thank you. Master lectures caught me many times when learning Zig. Yeah, happens. We need to come up with a better name for the allocator state. Not a Zig question, but what name would you choose for a zero pointer? Null, nil, or none? In Zig, it's null. It's a null pointer. In C also is a null pointer. In many languages it's null. I think the nil is in my mind, nil is basically means the same thing as null means. It's just fancier. And if I remember correctly, nil stands for not in list. So I think it's like a LSP thing, if I remember correctly. But I don't know. Python does none. Like if I were to choose for myself, probably I would choose either null or nil. Honestly, I personally like nil. I don't have any strong reasoning behind it. I just like nil. Const versus immutability is frustrating. Yeah. Zig doesn't have a way of really. By the way, there's another way of expressing immutability, right? I think that C++ has this, where the idea is this pointer cannot be used to write through, but like it's like transitive. So like that point, if that pointer is a pointer to a struct and the struct has other pointers, then you cannot even write through those if you start accessing it from the original immutable pointer. It's weird. Maybe it's frozen, the word for it. I don't know. It's a weird property, which I think it's also full of inconsistencies and problems. But in any case, yeah, this is some nuance that you have to keep in mind. The concept of your local value versus the value that's being pointed to by your thing. So yeah. Does it support GPU programming? Any reference suggestion? Where should I start? So Ali Reza, yeah, you can ask questions for sure, since you're also asking that after having asked the first question. So you're asking for permission after having done it. But yeah, you can totally do it. Also, if you have other questions, feel free to ask. So GPU programming, it depends what you mean. Are you talking about something like games, or are you talking something more like I want to have the GPU compute values for me, not for a game, but because I just want an algorithm to run on the GPU? In either case, the answer is yes, obviously. In the case of, well, I guess maybe even in both cases, there's nothing particularly unique about Zig for now. Like whatever, so think about, I don't know, you're thinking about CUDA. Yeah, for example, here Tanto Mordillo is mentioning CUDA. Are you thinking about programming CUDA? find a CUDA tutorial, and whatever that thing tells you to do, that's what you have to do also from Zig, which probably gonna mean like import some C library, call some instantiation functions, debug a bunch of GPU related problems that are gonna be painful, and then you're gonna be able to pull it off. But one potentially interesting thing that's gonna happen in the future is that we are working there, like Snaktron, Robin, for people who are familiar with him, is working on a Spear V backend for Zig. So in the future, you will be able to write Zig code that you will be able to compile to you will be able to target a GPU basically. Well, you will target Spear V to be precise, and that will allow your Zig code to run on the GPU. But we're not quite there yet. When we pass a struct without reference, compiler decides whether to pass it as a reference or copy. Isn't that against Zig's no hidden control flow philosophy? I mean, passing to a function as parameter. Why do you think so? You're not the first person, so Novigrad Merchant, you're not the first person to state, to ask that question, or in any case, state that it could be interpreted as hidden control flow. I think that the way in Zig hidden control flow is defined is slightly different, as in, okay, let me try to I guess to understand and stillman your perspective. So why would it be hidden control flow? Because if you're, or you know what, let me state the problem for other people watching in case they're not familiar. So the idea is this: you create a function called foo that accepts a person. And if you write this in Zig, and let's say the person is this, whatever. So if you write this, then foo looks like it's accepting a copy of the struct, but Zig reserves the right to decide if it's going to actually copy the value and give it to the function, or if it's going to secretly pass in a pointer. You, as the programmer, don't have to really worry about it because, how can I say? Well, let's just say at a surface level, when it comes to like simple reasoning, there might be more nuance with more complicated corner cases, but like generally speaking, you don't have to worry about it, because even you know, you could say, wait, but then that's a problem. If I do p.name equals banana, then if you gave me a copy, I'm modifying the copy. If you gave me a pointer, then I'm modifying the original instance, and that might be a problem. That's not a problem, because guess what? This value is immutable. Function arguments in Zig are immutable, so you are not allowed to modify it. So because of that, you can't do this. So whether it's given to you as a copy or as a pointer doesn't change anything. With a couple stars, because there are some corner cases where there might be more complicated things to think about, but let's set aside those for a moment. So, okay, what would hidden control flow be here? I guess you could say that hidden control flow would be that I guess you could say that there either could be a copy of the entire struct into what, a register, or like on the stack. I'm guessing, well, if let's assume that it's a big value. So I guess you either could have machine code that copies this entire value on a stack versus instead placing a pointer to this struct in a register. So you could have these two versions, right, of the function. Zig reserves the right to either copy the entire struct inside of foo's stack, or place a pointer in a CPU register, and then generate foo differently based on which one of these two options the compiler decided to go with. So you could say, well, these are two different things that are happening, and so maybe they are you consider them different control flow, but it's not really control flow, right? You're calling into foo no matter what. What changes is what type of operation is like what instruction is running before doing it. Like you also, I believe, don't know exactly. Let's assume that instead of being full person, it's like something simpler, right? It accepts A, that's U size, B, that's U size, C, that's U size. Also, in this case, you don't know if these values are gonna be passed via registers or if they're gonna go on the stack. And actually, the answer changes also based on which architecture you're targeting. Because if you're targeting an architecture that has a ton of registers that are big enough to hold a U size, then targeting that that architecture will give you the CPU register version. If instead you're targeting something super small, then all these values will have to go on the stack. And so you're going to get the other thing. So in general, I would say this distinction of whether you get a pointer to the struct or whether you get the full copy of the struct is meant to be transparent to you, the programmer, already based on which architecture you're targeting. So I don't think you should interpret this as hidden control flow. I would actually genuinely be interested in a reply. So Novigrad Merchant, if you're still here, I would genuinely be interested in hearing what you think about this answer that I gave you. Like, do you think this answer your concerns? Or do you think there's an interpretation of your perspective that I'm missing? I see now, thanks for the reply. Okay, so you seem satisfied. So yeah, that's the idea. Another thing that I should point out, this obviously is true in Zig because Zig doesn't have like copy constructors. So there is no user-defined code that could run on a copy. That's maybe something else to point out. Like if this were C++, actually, I'm not even sure. I assume that, when there's a feature, 99% of the time C++ is going to have it. So I'm guessing the C++ does have copy constructors. Maybe people in chat can confirm or deny this. But if you did have copy constructors, then obviously, yeah, it does. I think I learned the expression, like even the term copy constructor, I think I learned from C++. So, so in that case, obviously, this would totally be hidden control flow because, well, the concept of a copy constructor is hidden control flow by our definition. But in this case, it would be like super problematic, right? Because sometimes you get a copy happens, sometimes it doesn't. Like there's a potential for jankiness here that is like would be amazing. But Zig doesn't have any of this stuff, so yeah. Computing made is mostly for AI. Not sure if Zig is the best choice or not. Yeah, I'm sorry. I'm not sure. I would need to know more about the specifics of your use case to be able to answer. But what I would suggest is find information for C and C++. See how you like it and try to replicate that in Zig. You will find it's not that hard. You will find that it's actually easier. I would even suggest find instructions for C++ and use Zig to compile that C++ because you can do it. This reminds me of the talk Attack of Killer Features. Yep, that's the topic. That's the topic. Lee Cannon was also pointing it out. That's what we are discussing right now. It's PRO. It's parameter reference optimization. I think that's what the acronym stands for. So yeah. Any more Z questions? By the way, I'm actually looking forward to go work on my HTML parser, but if there's more questions, I'm happy to answer them. Also, let me check. Okay, you know what? I think I might take a quick break before coming back and doing the parser work. Did you do lead code to get the job? No, I did not. The last 2 jobs that I got did not require me to do any lead code. My previous job was at Redis Labs, and I got hired as a developer advocate. But they kind of scouted me because I wrote a Redis module. and they invited me to go speak at RedisConf. I wrote this. So basically, having done this work and having given a talk on this subject at their conference ended up basically being the equivalent of my technical interview. And also the position that I was going for wasn't like entirely technical. It was a developer advocacy position, which means that you ideally should be a decent software engineer. Ideally. Keyword ideally. But it's not just that. So I guess that I got lucky. That's what happened. My current job is at the Z Software Foundation, and no, I did not go through to this kind of thing. It would be really funny to see Andrew administer to people lead code style interviews. That said, I have heard that a lot of places have like this kind of hiring practice. So I don't know. That's just my experience. And I'm not saying that. Did you lead code ever or never yet? I have never lead coded. Never. But again, this is my experience. How can I say? I would imagine that if I were to, give up on the Zig ecosystem completely and just try to go and find a software engineering job outside, I would probably have to look into it, I would imagine. Is an async model similar to Golang being considered instead of async await? No, because an async model similar to Golang requires a runtime. Go works because behind the scenes, there's code that runs before your main function that sets up a bunch of stuff. And also, the execution of your code is intertwined with Golang runtime code. So Zig is a lower level programming language, and it doesn't want to have that kind of baggage. Let me tell you one example why having a runtime can be problematic. And again, it's trade-offs, right? So I'm not saying that it's inherently a bad idea. But if you want to build for WebAssembly, for example, and you use Go to build a Go program, so you write a Go program and you want to deploy it and you want to target WebAssembly, you will have to pull in the entire Go runtime, and you will build pretty chunky WASM files. And you will have annoying things to deal with when interoperating with other things. So that's the kind of downsides that you get by having a runtime, like a chunky runtime, like Go does. Async await has the upside that is like async await. Even though I understand that colloquially people contrast async await with like Go routines, for example, as being two different solutions. Async await, specifically in terms of language syntax, like the keyword async and the keyword await, and in the case of Zig, also the keyword suspend, resume, and a couple other built-ins that also Zig had related to that stuff, is just a language construct that changes how machine code is generated for a function. And well, I'm understating it a little bit. It does a little bit more. But the point is, async await in Zig as a language feature is not a full-fledged async await solution like it is maybe in Node. There's still, for example, the event loop that would still have to be userland code. Async await in Zig would only change how your function body gets translated to machine code. And that transformation, it basically turns a function into a multi-stage thing, where basically you can call into it and resume from not always start from the top, but sometimes also resume from the middle or every time there's a suspension point. But then orchestrating all of this happens with userland code. So in Zig, the event loop is not part of the runtime. The event loop is something that you as a user instantiate in your main function and use to kick off your async stuff. In Go, the way Go works, Go routines are deeply integrated with the runtime, with the event loop. For example, the Go compiler has to manually insert like yield points inside of for loops to make sure that a Go routine doesn't hoard a OS thread forever, that kind of thing. So I would say that the Go model, or here's another example. Go routines are stack full. So a Go routine has its own stack. And the problem with stacks is that they grow. And sometimes, like you have linear memory, right? Let me use like a tool, Lorian. So this is your, can I draw, Lorian, please? This is your memory. And maybe here's a stack for one thread. So this is the stack for T1. But then in Go, you have a bunch of other Go routines, right? So usually you have a stack per OS thread, but in Go, you have a stack per Go routine. So you have a bunch of stacks. So this is G1, G2, Go routine 2, etc. And the problem is, if G1 grows its stack a lot, because you have to grow your stack whenever you call into a new function. As you go deeper into the call stack, you need more frames. So it grows. You could get to a point where there's no more space for this stack to grow. So what do? You could error out. That's one way of doing it. But what the Go runtime does, and keep in mind, the problem is that these tiny stacks, they have to be placed one next to the other because you have a ton of Go routines going on at the same time in a Go web server, for example. And so you have a ton of those, and so you have to grow. You want to move this guy, and to move this guy, you have to copy the memory somewhere else, and you have to know what values are pointers, because all these pointers need to be updated. They need to be offset by how far you're copying the entire stack. And Go can do this because it has a runtime, it has a garbage collector. Everything that is a pointer, Go knows that is a pointer. But Zig doesn't have that. Zig loses all that runtime information because the final executable is super lightweight. Like if you look at how fat a Go program is, it's much fatter. Like there's a price for having this level of introspection ability. So long story short, this is cool stuff. Like the fact that Go is able to pull this cool stuff off is great for Go. But I'm pointing this out to say that this is a model that is really a bad fit for a systems level programming language. So the space that we're in kinda makes this thing, this way of doing concurrency, not the right trade-off. It would make us lose things that we don't want to lose. So async await for now seems to be the best. Linked list? No. You can, well, I guess technically maybe you can, but turning a stack into a linked list, man. You know what? It would actually be interesting if somebody were to try and have a OS or like a runtime like Go and try and pull stacks of as linked lists. But I think that it would be so bad. Like the normal code in your function body would have to, every time you're trying to access a local variable, the machine code would have to worry whether it's in which part of this linked list it is, and I think you would tank performance because of that. So people don't want to do this. Okay, so here's what I'm gonna do. If you want to stick around, I would like to do some HTML parser work. I pretty much haven't done anything, but I also need to take like a 20-minute break. I need to move for a bit. So here's what I'm gonna do. I'm gonna leave the stream open, and I'm gonna set an AFK timer for 20 minutes. Here's what I'll say. Then HTML. LSP. There we go. Sorry. feel free to, I don't know, move somewhere else if you need more high octane action. But I'll be back soon to do some more work. And if once I come back, there are more Zig related questions, I will be happy to answer them. So let's see. Alireza was asking, I have 15 years of experience as a software engineer with high-level languages. Now I want to learn more about low-level programming, but I struggle to find interesting problems to solve or write, or a path to start. Do you have any suggestions about easy ways to transition from high-level to low-level programming? For example, I finished Advent of Code in Zig, but I still don't know what to do with it. That is a fair point. So you know what? I'll quickly answer this and then I go. Advent of Code is nice to practice, but it's probably one of the things that really is not gonna show you what is the real point of Zig. Because with Advent of Code, you're not doing good software engineering. With Advent of Code, you're basically writing the least amount of code that you need to write to get to an answer. And Zig is not all about that. Zig is about error handling, managing memory, like long-running applications, designing all of these things that in my opinion, that's what software engineering is all about. Well, Advent of Code, it's more like data science almost than it is. It's like CS, computer science / data science, not software engineering. So you have to write the cool algorithm, maybe with a good implementation, but then you don't have to handle parsing errors for the input, right? Or like other conditions that have to do with like long running. Like you mentioned the GPU. If you want to write an application that uses the GPU and you want to make it really solid, you will have to handle the case where the GPU runs out of memory, for example, or where the GPU has been unplugged. Some GPUs can be hot plugged and hot unplugged. So these are real things, complicated things that you have to worry about if you want to make a good software engineering program. But it's dramatically different than what you have to do with Advent of Code. So, for example, here Michio Hashimoto has written this terminal emulator in Zig. It's called Ghosty, and this thing is great. But a terminal emulator is real software engineering thing, right? It's not like an Advent of Code problem. A terminal emulator has to be long running. You don't want it to crash on you and lose all your work, right? That kind of thing. So that's what you want to go for. To learn to appreciate Zig. And in my opinion, you need to look into maybe writing utilities, writing a parser for something. I'm writing an LSP, and you know what? Writing an LSP is not a bad use of Zig. It's long running and has to be decent enough to make it interesting to write it in Zig. That said, LSP has a lot of annoying bullshit because of the protocol. So maybe there are better examples out there. But I wrote a Twitch chat client also that was interesting. So I would say think about native CLI tools. That's maybe a way to start. And I don't know. Oh, there's a suggestion. In any case, I'm going to go eat food and I'll be right back. Yo, I'm back. Sorry for the delay. Sorry for the wait. Let's see, what did Lee Cannon say? This really shows that coroutines are not simple, but the syntax to use them is loads of people. Oh, but the syntax to use them is. Loads of people want to be simpler, like this, whereas actually makes it more complicated. More compilated. That's a funny typo. I suspect it's a typo. Yeah, but from my perspective, this is like, you know, easy versus simple. Go routines are easy, but they're not simple. They actually pull in extra complexity to make things easier. But again, it's actually a reasonable choice. Like Go routines, agents, that kind of stuff. I think it's not a bad programming model. I think that from my perspective, the main criticism you can aim at Go is that the way they implemented, you know, CSP is like very bare bones. And maybe they left on the plate a few things that would be nice maybe to have. Like if you think about like Erlang, where they have like process trees and they have the ability to restart processes and like have supervision chains and etc. That's all very cool stuff that you completely lose in Go. That said, that is a choice though, where they gave up certain features in exchange for simplicity. Like genuinely, Erlang is way more complicated than Go in its internals. I think we can state that with certainty. That said, yeah, okay. So, shall we, man, now that I have some food in my system, I feel so much more energetic. Like, even though I'm busy digesting, it's still so much better. Okay, so we are in a messy situation right now with our auto formatter. This becomes this, and that is weird. So here's what I would like to do. I would like to, I still have Johnny's example. I would like to actually see this example run. Cheers from Portugal. Hey. Oh, sorry. Before I get to you, Jose. Cyber Jesus. What? The bark thing looks nice. Is the source public? Yes, of course. It is. It's here. No, what am I typing? There's also pre-built releases, so check out the pre-built releases. I'm sending the link on YouTube for people who are on Twitch. They don't understand what's going on. Let's see. Cheers from Portugal, Loris. I've been following Zig for a while. Nice, and I'm curious to see where the community takes it. Awesome. Welcome, and enjoy your ride. Enjoy your stay. So right now I am bringing Zig to a HTML LSP that is doing sus stuff when auto formatting. So let's see where we can take that. So yeah, the first hello world has to stay glued together. The second one doesn't. This is true for span because it's an inline element. I forget what the correct word for it is. I think inline is correct, but I'm not sure. It's like when it's not a block. Yeah, I think it's inline. The problem is with CSS you can render as inline pretty much any element, so it's not, you cannot even say, well, it's a property of this tag. So in general, yeah, if things are glued together, you have to keep them glued together. And you observe this property when printing the opening tag of an element and observing that there is no white space before it. I think that is kind of the idea. And the same applies also to text nodes. Same text nodes follow the same rule. But if there is space, then yes, you can put a new line in there. So I think that that's kind of what we want to implement in our thing. So let's take a look at how the rendering code looks like, what reasoning it does on white space, and tweak it. I know you use VMware for Nix. Have you ever checked out OrbStuck? It's really good. I have no idea what OrbStuck is even. Oh. I am not using a Linux container though. I'm using a virtual machine. So well, let's see what this does. Yeah, these things works on the assumption that you just want terminal access to your VM. But in my case, I have a GUI and I want a GUI. Like I want to have a full desktop environment in my Linux. So it's a different situation. That said, if that's what you're going for, looks fancy. I could see myself using something like this. That said, you know, I want to stay away from containers. I think they just suck. So unless I really have to, I don't want to have Docker running on my computer. It's a waste of space and resources. Okay, let's take a look at the rendering code. So I guess we can close this. We don't care about it anymore. We are in the tokenizer. Now we're in the AST and we're building AST just fine. But now when we render it, we want to think about it more. So we are about to render the opening tag of an element. And we have to decide, do we want to go vertical or not? And our reasoning here is, first of all, if we are inside a PRE, we don't do any of that kind. We don't do any work of that kind. So let's ignore for a moment the case where we are inside a PRE. Vertical. We look at the what might be white space. This is interesting. So here we are looking at this, but that's not what we should do. So previously we were looking at some text because like this thing used to also include text. So now we don't need to do this anymore. Like the question is there any white space at all? As in, is this slice longer than 0? So basically these thing can be turned into kind of like this. If there is some white space, then yes, we're going to go vertical. Otherwise, we look at we look at this thing. If the last thing that we wrote down was a closing tag, and that thing was aligning itself vertically, then we want to go vertical as well. Unfortunately, we don't want to do this anymore. We can't do this anymore. That's unfortunate. Let me see if I can pull up an example of what this means. Let's take a look at an example of what this means. So this means that if this were to be like this, then we would want, so if the last one was vertically aligned, then we want to introduce a white space here. Is this okay? Like, is this transformation okay to do? I think it's not, right? You think it's okay, Arnau? I don't think it is. Or rather, I would agree that it is in this specific case, but it is not necessarily correct. Because check this out. Actually, I shouldn't do color. I should do background. So when it's like this, that's what it looks like. But then if we introduce a new line here, it looks the same. That is interesting. That is indeed interesting. So the fact that the previous tag already had some white space means that that any white space here in between can be ignored. I didn't know this. But if this instead was horizontal, then now it does have a meaning. Now it puts something in between. Okay, so it means that the presence of white space in the previous element makes the presence or absence of white space now at the boundary between elements not relevant. Neither the stack of open elements nor the insertion mode changes, so they're equivalent. Oh. By the way, that's a level of understanding of the spec that, you know, I didn't get down to that level. I probably should read the spec also. Do you have like a link to the section where this stuff is defined? Honestly, if I have to be honest with this auto formatting stuff, I've kind of been going by examples. So the presence of white space in the previous element means that we can do white space in the current element. But that's only for the left side, right? That doesn't necessarily mean that we have a license to do white space here on the right side. Maybe it's not going to change anything in this case, but adding white space here to the right side is a problem because it's kind of basically, because the equivalent, it's kind of doing the same thing as adding white space here, which goes from, so this is what it looks like without that white space, and then this is what it looks with that white space. So we are borking things. So no, the fact that the previous element was rendered vertically, if there is no space between these two tags, does not give us a license always to also add white, to also align our element here vertically. So I would say no, we cannot do this. That's unfortunate. Thank you. Let me check it out. Copy link. Okay, so sorry. This is the general spec. Like, where can I learn more about what white space does two things or doesn't do two things? Because it's reconstruction, speculative HTML parsing, coercing all HTML DOM into an info set, misnested tags. Oh god. The parsing of this markup is straightforward up to 3. At this point, the DOM looks like this. Yeah, this is like B and I intertwine, right? Yeah, that's fucked up. So what does this do? I guess it explains all the recovery, but whatever. We don't care, I think. Insertion mode under parser state. Thank you very much. Parser state. Insertion mode. The insertion mode is a static variable, is a state variable that controls the primary operation of the tree construction stage. Insertion mode is initial and can change to before HTML, before head, in head, no script, after head, in body, text, in table text, in caption, in column group, in table body, in row, in cell, in select, in table. Jesus Christ, in table, after body, in frame set, after frame set, after body? Huh? And after frame set. Several of these modes, namely in head, in body, in table, in select, are special, in that the other modes defer to them at various times. When the algorithm below says that the user agent is to do something using the rules for the M insertion mode, where M is one of those modes, the user agent must use the rules described under the M insertion mode section. Yeah, okay, like holy shit, how so many words to say. Yeah, when the thing says that you should refer to in head mode, you should actually refer to the instructions specified in the in head section. Yeah, I get it. When insertion mode is switched to text, the original insertion mode is also set. This is the insertion mode to which the reconstruction stage will return. Okay. A character token. This can never be a null character. The tokenizer converts those to replacement characters. Oh, this also is interesting. So also the presence of null bytes in your HTML stuff. I don't know, man. I think that I kinda am tempted to make my HTML strings just not accept null, period. And that means like not just have like how can I say, like parser things that the parser does to handle that case. I'm thinking of even defining the HTML bytes as a null terminated list. It basically gives you a state machine, yeah, which describes how to construct the AST. Like, not really a tree. You don't need to do so, but you should kind of follow it to detect errors at least. Yeah, that makes sense. Yeah, that makes sense. Although in this case, since I'm still working on the formatter, I'm just deciding what the formatter should work. Although that's a fair point. Yeah, I should read the spec. So let me fix the auto formatter a little bit to see if we can make it, you know, not misbehave. So we don't care about this anymore. So we're trying to enter If there was some white space to the left, then maybe we consider verticality. So we add a new line, we indent as needed, increase indentation level, and then print the thing. And here we print the thing, and that's fine. Then here we say, okay, we are exiting something. Also, don't follow the spec 100%. It's very painful, especially with UTF-8 stuff. Yeah. No, don't worry. I like your comments are now. Don't worry. Yeah, with UTF-8 stuff, I'm also not following it to a T either, because in any case, I'm working for, like, I'm making an auto formatter for dev tooling, and like, sure, you would want it to like report certain errors, but like at the same time, I don't know. If you're editing a file that has a null character in it, why even is there a null character in the first place? So, like I like this thing has, like, the idea is, okay, you're a browser and your user has just accessed a web page that happens to have a null byte in it. What do you do at that point? And in that case, it makes sense to have recovery strategies, turn the null character into like a diamond question mark thingy. All those things that they do make sense. But for developer tuning, it doesn't have to be so complicated. Like if you're editing a file, in any case. Also, another thing that I'm doing is I want my thing to only follow UTF-8. So my parser isn't able to parse UTF-16 or UTF-32 encoded HTML pages. And that's like kind of by design. I just don't care about solving that use case for now. Things like space-like characters, there are multiple bytes. So those will also count as white space then, like Unicode spaces that aren't the usual suspects, like the usual ASCII suspects, they also will count as white space. If you expect, you cannot have a typical tokenizer. Yeah. That said, okay, that is something actually that I might be interested in doing in the future. Like the Unicode stuff is actually what doesn't scare me. I'm not doing it to a T right now. I'm still only considering white space, new lines, spaces, and tabs, that kind of stuff. But I can see changing that in the future. It's actually pretty easy to fulfill these requirements in Zig. There's a library called Zigleaf or Zig str. Let's go with Zig str, which is now on Codeberg. So this library implements all of Unicode for Zig, and it can tell you everything. It can tell you, like, is this Unicode thing a white space or not? How many characters it should be? Like every weird Unicode question that you might have, you can answer it with this library. It's really good. I'm using it here. I'm using it in my Twitch chat client, and like if you were to use weird, like if you're were to use like maybe Japanese characters or Chinese characters or like Arabic, that kind of stuff. It's gonna work, like it's gonna render correctly. And this here, this is a terminal, right? So like deciding how many words you can put on a line, like text not indentation, but like line breaks, basically. I'm computing them manually, so I'm manually deciding that painful doesn't fit here, and so I'm gonna move the entire word to a new line. And so splitting on words, understanding how many cells that word is going to occupy, and do then all the math correctly, I'm doing with this library. HTML can contain bad sequences inside C data. Oh Jesus. Yeah. Okay. This is fine. Now we have to ask now we're asking ourselves the question of, we're closing. Do we do vertical alignment while closing? And the question is, oh, here I'm doing this, but now I need to ask a different question. And the question is, let me think about it for a moment. So current open end source at current open end. So source at current open end is just wrong. Let's just say that this is just wrong. So this condition is just wrong. Okay, let's redo it from scratch. That's just wrong. Okay, I'm about to render the end tag of an element, and I have to decide if I want to put it on the same line or on a new line. What I have to check is the last thing that I printed, and the question is, the last thing that I printed, is there any white space between that thing and where we are now? And if so, we can reconfigure that white space. Otherwise, if there's no white space in between, we have to respect. We cannot add extra white space. So that's the entirety of it. So I look at the last R bracket. That's the index where the last element ended. I call it R bracket. That works for elements. For text nodes, there is no right bracket, but that is still the same variable. So I'm basically asking, okay, is there any white space in here? If there is any white space, then we want to reconfigure it, basically. So I think this should go outside. And then we should say if there was white space, then we put our own white space. Hello, Rocco Rager. Hello, hello. Okay, I think this does make sense. We still have one problem though. I do not expect this to work correctly because I think we still have one problem in the tokenizer. We still have one problem in the tokenizer. Oh yeah, this is where the offset math was wrong. Now I remember. This is where I wrote that inappropriate thing. This is where I wrote that inappropriate thing. So let's do better. Let's do better than this. So we don't want to trim anything anymore. Because now we expect this thing to be precise. Also in the case of text. And let's go have the tokenizer work correctly. So the tokenizer is right now correctly ignoring leading white space before text arrives, but it is not correctly chopping away trading white space. So when it's returning this text token, it's just basically stopping right before this thing, but it's not realizing that there's some white space there. So how do we do this? I guess what we want to do is we could keep a count. We could keep a count that says that counts how many contiguous white spaces are there. And as we are about to return the token, we subtract from the suffix that many bytes, basically. That would work. Let's do it. So we have in our text state, we have a white space streak. You know what? That also makes it so that we don't need whites only anymore. Nah, whatever. Let's leave it. Let's leave it there. Okay, so we have white space streak. So what do we want to do with it? As we add a new character in, so this is keeping suffixes, then great. Sorry, this is keeping a prefix, but then we found some text, and now we're maybe found just now white space. So what do we want to do here? I guess we want to do this. If it is white space, increase white space streak, else we reset it whenever we encounter a character that is in white space. And then when we are returning a token, which we do here, but this is like error handling. It's kind of weird. Well, in any case, we can do it. -self.state.text. We subtract the white space streak, basically. Okay, that seems reasonable to me. So that should allow us to keep to skip the suffix. Do we build? We did build. That's interesting. Let's look at the test. What does it look like? Oh no. Start index 179 is larger than index 0. Uh-oh. AST 346. Something doesn't have a close start. 346 in the AST. Oh, I think I know who doesn't have that. So yeah, actually it's a problem. Wait a minute. Are we like exiting? Like this crash, it's making me think that we're like trying to exit a span. We might want to do some printing, I think. We probably want to know 246. We probably want to know in where is it? Yeah, here. What is it that we're looking at? Because in reality, we should not be exiting a text node. Like we enter a text node, yes. But then we continue. You know what? Let's add an assert. Actually, it's not even that. Text, where is it? The direction for a text node is, well, no, direction is after, and that is fine. But enter exit. Wait a second. Direction is Okay, yeah, then let's do add the assert. So std debug.assert. We should never be with an exit direction when doing text. And I guess we can assert here that we're not things that we're not exiting from. Yeah, you know what? Let's do this. Yeah, let's add some asserts and see how that goes. Maybe we could put the assets on top. Are you building a general parser first, or is this just for HTML? What is a even more general parser than an HTML parser? As in, usually a parser is tailored to the language that you want to parse. It's like normally a parser is not just for like a bunch of languages all at once. That said, you know what? It might be legitimate to ask whether like these HTML parsers should also maybe do, I don't know, CSS or like deal with some of the things that are usually embedded in HTML, which is a legitimate question, I guess. But, or maybe you're asking if I'm writing, I don't know, like a parser generator. And no, I'm not writing a parser generator. I'm handwriting a parser specifically for HTML. Okay, so it seems that we're not hitting any assertion, which is interesting. So now the question is, why does something not have their closing tag written down? Hello, Mr. Christoph. Hello, Reed Hulkamesh. So I expected like text to, for example, not have that. But then which node are we in when this happens? We should actually kind of know, right? So we have info from the tokenizer. Do we print anything from the this guy? Oh yeah, we do print. It's just that it's a log debug thing, unfortunately, which doesn't show up in tests. I guess I was wondering if you were doing a parser or generator. I see. No worries. I'm not running a parser generator because, honestly, you know what? That is one thing that I wouldn't do. I feel like that if I'm at a point where I'm using a parser generator, I would just use a pre-existing parser generator. But in this case, I am writing by hand my parser logic because I want to have full control over how everything works. Oh, we are having trouble with BR. Oh, man. Such a silly bug, man. You know why we have a problem with BR? Because we don't have it in our list of void tags. So we don't recognize that it's a void tag. That was the entirety of the problem. That looks correct behavior to me. This is what we were given, and this is what we produced. Oh, sorry. This is what we produced. I think we're good. This has to stay how it is because there is no white space for us to play around with. But this one doesn't have to, and we decided that this auto formatter I guess it prioritizes vertical alignment over horizontal. So if it sees something like this, it's gonna try to put this thing on the second line. That tracks. So we're not passing the test, but we can make it pass now. So let's go to where the test is, and then what we're gonna say is that this is the case, and this is the expected solution. And the expected solution is pretty much the same, but with this. So let's watch. By the way, void tags for the HTML namespace are well defined. Oh yeah, I know. I'm just being super lazy. I'm getting there, by the way. It's like I'm getting there bit by bit. But right now, I want to. I'm designing another thing, so I'll show you in 1 second. So we passed our test, which is nice. So we can zig build. We're building the parser, but we're also building the parser inside of the LSP. So here we open Helix, and guess what? Now we, can I recover the original example? Okay, the LSP crashed. That makes sense. So I know why it's crashing. It's kind of crashing by design, let's say. I think. Oh no! I have 2 instances of this thing. Close this terminal. Okay. Let's see what's going on here. Yeah, it's by design because I still have some to-do branches for malformed HTML. So as I'm editing it, I'm hitting those branches because it tries to parse the document at every keystroke. So I'll get to it. I'm getting to it. It's not like I'll get to it in the far future. I'll get to it soon enough. But now I'm trying to do something else. So let me save. And we crash. Okay, what happened? To do implement element self-closing. Oh shit, right, because I copied the original one that has this stupid goddamn self-closing element thing that I haven't implemented. So let me restart the LSP, and now let me save. Okay, and now we have the auto formatter going. So this is what the auto formatter is doing. I would say not bad. Check this out also. Check also what other thing my auto formatter is able to do. Let's say that you have an element where you start adding a bunch of stuff. So ID equals foo, class equals bar, banana equals, I don't know, each something something. So you write this, and at some point you have so many attributes that you want to align them vertically. Guess how you do it using my tool? You put a space here, so a space in here. I guess, oh, you know what happened? I was typing. As I was typing, I generated invalid HTML, so I need to restart, sorry. Okay, I restarted the LSP. So you save, and it does vertical alignment of the attributes. And then if you want to restore the horizontal alignment, you remove any white space in here, and now it will automatically pull everything back up, which I think is nice. Yeah, ZLS style. Well, no, sorry. No. It's not ZLS style. That's the Zig auto formatter. So you might be accessing that functionality through ZLS. That's fair. But that comes from Zig, the language. It wasn't designed by third parties. But yeah, that setting aside, sorry, that nitpick, that's the thing. What does it do if you put a space inside the span on the first example? Inside the span, like here, it does this. Not great, huh? I guess what we should check is, because it's kind of prioritizing, like every time it is allowed to go vertical, it goes vertical. But right now it's not taking into account what we ended up doing with the opening tag. So I think what we should do is, when making a decision, oh, and also I should also, here's another, okay, I remember now why I had the previous behavior. I also had some of the previous behavior because one thing that I wanted to do was this. Placing a space here, I originally wanted that I originally wanted placing a space here to be a way of communicating to the auto formatter. Then now you want to align vertically the content of this element. The problem is that you see how expressing intent as a user to request a behavior can be a little bit at odds with HTML semantics. That's annoying. So the variable that I deleted, the one that says did the last thing end up with vertical alignment, that's what it was meant to drive. So like you would be able to put a space here, and putting a space here automatically introduces space on the other end. Honestly, I am starting to think that maybe I should restore that behavior and say, I'm kinda, how can I say? I will not allow you to have this construct in your HTML, but you can still obtain the same behavior some other way. Actually, can you? Yeah, but not having a space here. Honestly, I'm tempted to re-implement this. Putting a space here should get you here. Yeah, you always have the other escape thing, huh? That is indeed true. That is indeed true. On one hand, but on the other, here's the other problem, is that you put a space here and the result is that I add a space here, and that might be annoying. What about a space? Yeah, if you, so with this thing that I'm describing implemented, it would align, it would do this. It would do this. And you know, Arnaud, you seem knowledgeable about this stuff, so maybe you can answer my question. I have a vague memory, actually not vague, I have a clear memory that introducing white space inside an anchor tag at some point used to be a problem, because it would add, like, it would basically underline also one space extra. And yet I tested it recently and I could not replicate that behavior. Like, if I do this, if I load this in an editor, if I load this, in a browser, I will not see any space being underlined because of the anchor. And I remember that this used to be a thing, and it's not anymore. As you can see, there is no white space that ends up becoming a link. So, what can you tell me about this? I remember that this was a problem, because introducing a space between this B and A could be a problem. Let's assume that this initial space is intended. What if you remove the doc type? Yeah, I thought that too. I think you know what? I think I tested this, and I think I still get the same behavior. So even with the quirk stuff. Yeah, but it doesn't change this, apparently. It might be that browsers just have changed their behavior in this regard, and they don't even, lock it behind the doc type thing. They just changed their behavior wholesale, and that's it. They just adopted the new behavior and broke retrocompatibility with all their websites. So thinking about all this stuff, also with span, let me do this. So not even a span. I'm placing a non-new line space. Changes nothing. So it's just fine, I guess. Okay, so here's my conclusion, okay? My conclusion is that it seems reasonable to do it like this. We kind of have two modes for tags, which is either tightly coupled. So let's look at these two spans here. You can have two modes, either tightly coupled or non-tightly coupled. In the model that we have for our formatter, it's one of the two. We do not have, things done halfway. So it means that this and this, it means that these two cases will both become this case or this case. So basically we don't, these are like, how can I say, these are like unstable constructions that the formatter will always have converged to either this or this. So it's either tight or non-tight, and that's it. And if you want to simulate this, assuming that the extra spaces end up having meaning, if you want to simulate this, then you're expected to do ampersand white space. I don't remember what the heck my ampersand is. Like this. You do it like this if you want to simulate one of these two guys. What you get in exchange is that this looks at the leading white space to transform this into this, and this looks at the leading tightness to become this, well, without the white space. And that way, with one keystroke, basically, you can drive a bunch of auto-formatting, refactoring things in case you need to. I'll go with that. That's gonna be what I want to go for. So let's try to make this happen. I think I have to reintroduce then the variable that I just deleted. God damn it. I guess we will re-add it. Okay, last was open and vertical. So we are rendering an open tag. That's not interesting for now. We are rendering a closing tag, and we have to decide if we want to go vertical or not. If we want to go vertical, and going vertical or not doesn't just depend on the white space. Actually, it doesn't depend on the current white space at all. It does not depend on the current white space at all. It only, you know what, I can maybe place this here and place this here. What it depends on is our choice to go vertical. What makes up our choice to go vertical? We go vertical based on the decision that we made when we printed the open tag. I think this was called last. I think that's the semantic. Like, the question is, was the last open tag aligned vertically? Can we ask this question? Yeah, we just kind of ask this question independently of our white space situation right now. That makes total sense. Oh yeah, I already have this implemented. If you are in PRE mode, we don't touch anything. We just replicate verbatim whatever was there. This is what this thing does. PRE keeps track of how many PRE tags we are into. Every time we enter a PRE tag, we add one. Every time we exit a PRE tag, we remove one. And as long as we are greater than 0, we just print everything verbatim. Don't touch it. Okay, we care about this decision. Where do we make this decision? We make this decision up here. Here we decide if we want to go vertical or not. So okay, let's start implementing it. I think there's some more nuance that I'm not accounting for. I think that text nodes will need some extra care to implement, to design exactly what we want to happen in like text that isn't inside of a wrapping tag. Let's see. Here we are choosing for ourselves, right? Yeah, here we're choosing like, is there any white space? Okay, let me think about it for a moment. Here we're choosing, we're about to print an open tag. And we're choosing if there's any white space left to us to go vertical or not. Is this it? Yes. But this is not the moment where we care about this stuff. We care about this once we have printed this. No? Oh, no. I'm starting to remember. Okay, I'm like re-speed running my decision making. We actually want to do... We want to go vertical with the closing tag if the open tag +1 had a space. That's what we want. Yeah, that is our decision making here. Okay, let's I'm probably forgetting something. So let's see what the behavior is with this implemented. So let's rebuild the LSP. And I see what happens. Let's see. I am going to introduce a space here. Vertical alignment. I'm going to remove that space. Horizontal alignment. I think, yeah, that's the behavior that we want. So here I am going to say, you know what? I want undesigned thing to be vertical. Boom. It works. This stranded closing diamond bracket is annoying. You could maybe argue, you know what? I don't know what people's sensibilities are with this stuff, but you could argue that this is visually more pleasing, having this closing diamond bracket be on that same line. The problem is that we need this to be a configuration that tells the formatter to go back up. Otherwise, we are not able to undo. We would be able to split vertically, but then we wouldn't be able to return up. That's the problem. If there's a new line character anywhere in the text, go vertical. Otherwise, remove all white space. You think so? Honestly, I would think that even a space should be enough to communicate the intent. You could argue that a new line is what should drive this. That would be a reasonable statement. Like a reasonable way of making it work. But I think it's not, I don't know, you know what? For now, I feel like a space is, I'm happy to also have this work off of a space. Makes it easier to reverse it. That's fair. That's fair. I'll think about it. I'll think about it. Okay, so I think we nailed this behavior. Is this it? Did we really do it? We are respecting this. So we're not adding white space. We're not adding white space between these two spans. We are still printing them horizontally aligned. What happens if I do this? Yeah. That's good. What happens if I do this though? This is what I was referring to. I think that this is not handled correctly. Let's see. Oh, maybe it is. What if I add a space? It goes on a new line. Okay. Never mind. What if I do this? Yeah. What if I do this? It doesn't split it here. That might even be not that wrong. That's maybe... Should we? Like, should we kinda... Even though there is no tag around this guy, should we somehow do this? I don't know. You know what? I also think it's not all that important. I also think that you shouldn't be putting text between tags unwrapped. It's or you know what? Giving you like less auto stuff and more flexibility for you to format these things how you like them. It's better. Create a poll to decide it. Okay, no. I'm not gonna do that. I think it's fine. So we achieved that. That's not bad. That's not bad. So we have a auto formatter that is almost useful. Almost. Not quite useful, but almost. I think I need to start tackling all the to-dos that relate to errors. Like here, there's a to-do whenever we encounter a parse error and the direction is after. So we need to decide what to do in these cases. But that's not bad. That's not bad indeed. So I think I'm going to stop here with the stream. It was kind of a short stream also because it was interrupted by my dinner in the middle. But yeah, we had some good chats and we made some genuine progress. The auto formatting behavior is pretty decent at this point. Let me see. Space. Boom. Boom. Not bad. Not bad. I'll take it. I'll take it. Honestly, these okay, except crashing when typing malformed HTML because of to-dos. This is already better than what I get from the out-of-the-box LSP. What does the code look like to implement the LSP? Oh, it's not that complicated because I have I'm cheating. I have a nice dependency for this. So let me show you my zone file, the one for super. Check what I'm depending on. I'm depending on Zig LSP kit. So by depending on Zig LSP kit, well, let me show you the main function maybe. I think I call it CLI here. So the CLI program has an LSP subcommand. By the way, I want also the auto formatting behavior to be available as a FMT subcommand so that you don't have to buy into the whole LSP just to get auto formatting. So you will be able to just do, you know, super FMT, wire it into an editor that doesn't have LSP support, and it's gonna work. But the idea is you call this, this sends you to the LSP main function defined in LSP, and the way it works is that I import Zig LSP kit as a dependency, and then I instantiate an LSP server based on a type that I provide. The type that you have to provide, well, I have to provide, or like users have to provide, is basically just a bunch of callbacks, right? You can define whatever state you want to have, but all you have to do is implement callbacks for the main LSP lifecycle. So like you need to initialize and to advertise what capabilities you're going to offer to the editor. A bunch of those are not even implemented. They do nothing. You have to react to when a new document is open, when it gets changed, when it gets saved, closed, blah, 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 completion, go to definition. Like, for example, right now I don't have any of this stuff implemented, but we can also implement auto completion, and we can implement also go to definition, maybe. Hover, references, auto formatting. This is what I've implemented now. So whenever the editor is configured to ask for auto formatting on save, so whenever you save in Helix, so this is like a Helix setting. So here, but it's not unique. So whenever you save in Helix, an auto formatting request gets sent to the language server. The language server receives it, finds the gets the file data, the file AST. Looks if the AST has errors in it, it doesn't do any auto formatting. In this part, we just don't do any auto formatting because it's malformed, so we don't touch it. But what you're not seeing, because it's not implemented, is the callback with diagnostics, where the diagnostics callback would instead do the opposite. It would look at the errors array and report as diagnostics all the errors mentioned in there. So in any case, assuming that we don't have any errors, I render the AST and just send the reply. This API is pretty decent because every request has an arena that gets automatically reset by the LSP server once you're done replying to a request. So like you can put a bunch of stuff in the arena. In my case, I render into the arena, I believe. Do I not render into the arena? Oh, no, right. This is interesting. This is an interesting corner case. I'm not using the arena to buffer the rendered version of the source code, because this rendered version of the source code will become my new, how can I say, that's going to be the new value of the document itself. So I want for it to survive, because I'm going to need to reference it next time that another request comes in. So it's kind of a interesting corner case. Like, we are editing the file here in this sense, and that's a long-lived thing. But normally, whenever you have to do like intermediate allocations, you put them in the arena. The arena gets reset automatically by the language server kit once your callback is done running and a reply has been sent, and that's it. So ultimately, it's actually not really all that bad to implement LSPs. Like, this is my second LSP server, and it was kind of a blast to grab the old source code from my previous LSP and start repurposing it. So I highly recommend you check out Zig LSP Kit. If you program in Zig and you want to make an LSP. What's your end goal with it? My end goal is to have an LSP that can be useful. I'm a good judge your LSP code. Wait, are you interested in the LSP kit itself, like just the boilerplate, or are you interested in the specifics of this language server implementation that I'm doing right now for HTML? Because this one I haven't pushed yet, but I think as soon as it stops crashing whenever you type stuff in the editor, I think I'm gonna finally break super away from Zine and give it its own dedicated repository. In any case, teaser cake. My end goal with this project is to write a templating language that is an alternative to Jinja, Mustache, Handlebars, all these things. It's already implemented, actually. I'm just making it better. So I'm working on a static site generator called Zine, like in magazine. And I'm designing also my templating language. And my templating language doesn't have curly braces like the ones that I just described, but instead it does templating via I'm skipping down to the logic, to the part where I show you what the logic looks like in the templating language, to give you an idea. So this is what it looks like. Basically, the logic is special attributes. you use these special attributes to define your logic. So here, for example, if is an attribute that will get evaluated by the templating system and to decide whether to print the body of this element or not. Loops also work similarly. So here I'm looping over page.tags, which the $page allows you to access the front matter of a blog post, for example. And it copies the body at every loop. There's also an inline loop that basically copies the entire element itself. So like the idea is that the main tool should be used in a structured way by you. But sometimes you need an escape hatch and you have it with an inline loop. So this is what I'm implementing, and it works. It's already implemented, not perfectly, still some missing things, but it can be used. The thing is, though, I was depending. So to create an AST of my templating language, you first need to build an AST for HTML. Is Zine built specifically for HTML templating? Well, Zine is the full static site generator. The templating language was created as part of Zine, but it doesn't need to live inside of Zine necessarily, because it can be used also by other things. Like imagine that you make a web server and you need a templating language in the web server. You should be able to use it, right? But that's not Zine. That's what I call super. So I call them super templates. So yeah, it's a templating language. So sorry for the nitpick, just that we don't get confused about terminology. So the super templating language has been specifically designed for templating HTML, because my goal here, like Jinja and company, to be fair, they can be used for things that aren't HTML. They are very versatile. But downside is that they allow you to generate malformed HTML in a blink of an eye. They are basically like Jinja and company are like a language that exists above the HTML layer. In my case, instead, it's part of the HTML. It requires well-formed HTML. And my goal is to turn bad HTML into a build error. So this Zine is already able to do this today. You try to build. This is what you have in page.html, like h1. You try to build it and it gives an error. It's missing. It says that this element, h1, is missing a corresponding closing tag. Which, funny enough, this is actually valid HTML. According to the HTML spec, and by the way, I think that Arnau, who's like a super expert, can vouch for what I'm about to say, or correct me if I'm wrong. But you are allowed to not close certain tags in HTML, and I do not care, because the reality is that when you're handwriting some HTML, if you do something like this, you have 100% forgot to put a slash here. So I'm basically writing a static site generator plus templating language that is able to detect and complain about malformed HTML. Here's another thing that I already support. You have a double ID attribute. Well, guess what? That's a problem. ID attributes, well, HTML elements cannot contain duplicated attributes. And so it's a build error. And I tell you, look, this is where you have one. This is where you put the second one. This is kind of silly, right? Because they are one next to the other. And in fact, you're not easily going to have duplicated attributes in such a tiny example. But you remember the vertical example. It's not that impossible to duplicate accidentally an attribute when you have a bunch of them and they're stuck vertically. So I make this a build error. This already works. And sorry, I spent a bunch of time explaining the current situation, like the current context. Now to answer specifically about the work that I'm doing right now. Also because I'm saying that this stuff already works. How can this work if I'm working on an HTML parser right now and it's like super broken still? Well, the answer is that right now I'm using 3-seater to parse HTML. And 3-seater is good at many things, but whenever it parses something that is malformed, the AST becomes all kinds of wonky. And it becomes not very good if you want to provide diagnostics to people. So I'm writing my own parser to replace 3-seater. So right now I have a 3-seater parser that gives me an HTML AST, and then I use that to build my super templating language AST with all the, let's say, higher level logic. And now I'm busy replacing 3-seater with my own implementation. Because when things go wrong, in some cases, I noticed that 3-seater was giving me ASTs that I had trouble interpret to see what was wrong. So by being in control of how the AST gets generated, my hope is that I can produce better diagnostics. Also, the diagnostics that you see here are on build. So this is like the build process that fails and gives you diagnostics. In my case, right now, since I'm working on this stuff, I want to give you developer tooling. So I want to give an LSP that is able to give you these diagnostics even without invoking a full build step. So I'm working on this developer tooling thing. That's what I'm working on then. Let's see. I've recently created a blog and I wrote my own tool in Python. It's so buggy. I'm gonna put it to Zine. Be careful though. Zine is also buggy. That said, some things work with Zine. If you are interested in Zine, so keeping in mind that I'm not joking here. Zine is alpha software. Using Zine today means participating in its development. No joke. But if you're interested in following the development of Zine, join my Discord server. There's a link on YouTube, on Twitch, everywhere. It's the Software You Can Love Discord server. And I have a Zine channel, so we can talk about Zine. Or you can ask questions, because you're guaranteed to hit something wrong. In any case, check out the docs and see if you like the vision. That's what I'm going for. Also, this website itself, guess what? It's a Zine website. So the official Zine website is written in Zine, and well, at least this level of complexity is handled by the current implementation of Zine. Also, check this out: syntax highlighting, right? This syntax highlighting is static. I use 3-seater, so I depend on 3-seater for syntax highlighting, and it will stay that way. I am not going to replace 3-seater for syntax highlighting, but I am going to replace it for parsing the HTML of my templates. If you don't have the doc type HTML, like, okay, if you are in Quirks mode, you can do almost everything as long as it doesn't contain tokenization errors. Parse errors have defined rules to recover from them. I see. Lastly, this is maybe more for Arnaud than other people, since Arnaud, you're more familiar with the specifics of parsing HTML. This parser, this HTML parser that I'm writing, it would be nice to make it more general purpose over time, but I am very skewed towards supporting the HTML5, the UTF-8 encoded HTML5 use case. I'm not interested in other kinds of HTML. I'm not interested in other encodings other than UTF-8. So this is like kind of my starting point and my main goal. When this is achieved, once all this stuff is fully solved, then I'm happy to open discussion to maybe other encodings and maybe support for semantics that aren't the ones from HTML5. But the point is that I'm writing this parser for a static site generator, right? And the expectation is that you're handwriting your templates. So because of that, obviously HTML5 plus a normal encoding, UTF-8, is my main use case. I'm pretty sure not even Gecko's parser supports new extensions like XHTML. Yeah, I don't know. My experience is that not super extensive, but like my experience with looking at developer tooling, it tends to support like a weird mix of HTML plus XHTML without being like too precise about it. Like 3-seater understands void tags, but it also doesn't bat an eye when you have self-closing tags. Actually, not only that, like check this out. Actually, you know what? I don't remember how this behaves. Let me see. Playground. Okay, with this we have a div element that contains the line break. What happens if I self-close this div? You see, if I self-close the div, now the div doesn't contain the BR anymore. Oh, and I don't know what's going on. Occasionally this website crashes Safari. Apple moment, I guess. And if I put an extra div, it doesn't make it match, right? This behavior, it doesn't match what browsers do. I believe that browsers are expected to ignore this. And so this div will basically, having or not having this, should be the same under HTML5. And you know what? We can put the doc type here, but putting a doc type there doesn't change the behavior of three-seater. It's still gonna parse it the same. Oh, it thinks that div is an erroneous end tag of the BR element. Goddamn three-seater. So, as I mentioned, three-seater has very weird ideas about how to parse stuff that isn't correct. Shouldn't this be fixable using a custom grammar? No, or rather, maybe yes to some degree. The problem is, you know, you don't get to decide exactly the parser behavior. You only get to tweak the grammar. And so you have some indirection there, right? So maybe if you're somebody who knows very well three-seater, the ins and outs of three-seater, you can tell right away if a given behavior can be achieved through three-seater or not. You know, when analyzing something that has syntax errors in it and how to get there. But I don't have that knowledge. So when I write a grammar, I try to write something that makes sense to me. And obviously I can do some, you know, testing. Like I can write it in one way, see how three-seater behaves, tweak it, and see if I can get another behavior. But this indirection is, it's a tragedy, right? It's very different than writing the parser directly and fine-tuning the behavior by changing the actual final code. So your answer, I think, is potentially yes in theory. It is not guaranteed because I don't know exactly what it is that you can or cannot make do. You can or cannot make three-seater do by changing the grammar. But yes, I know that a different grammar that you know defines the same language just in a different way could have the parser behave differently in the face of errors. But in practice, man, that's not what I want to do. Also because you don't even know how much of that behavior is something that you can rely on versus being a quirk of a specific version of three-seater. So like imagine that you implement something that only works correctly with an old version of three-seater. It's like, it would be super horribly annoying. Ultimately, it would be too fragile. So I want to just have full control over the thing. Yes, you have the pain of having to write an HTML parser, but it's not the end of the world. And you, in the like, you know, what you get at the other hand of the very dark tunnel is the delicious light of really defining the developer experience. So, the spec defines some tags that cannot be self-closed. The thing is, three-seater is not fully spec compliant as far as I know. Yeah, sorry. The reason why I brought this up is in relation to your previous comment, right? I think this one. So the point being is, it's not only three-seater. There's a ton of developer tooling that is vaguely spec compliant, like very vaguely spec compliant. Let me show you one last thing. So, do you have a stream schedule? I have never seen you live. My stream schedule is usually around this time. So it's usually between 4 or 5 hours ago up until now, usually. Usually I end a little bit earlier and start a little bit earlier. Today I started a little bit later, but this tends to be my schedule. If you want to be notified, join the Discord server, and when you choose channels and roles, there's like this role that you can get. That basically, if you have this role, you will get pinged when I go live, in case you're interested. So, by the way, this is a way that you can get notifications because I announced that I go live in every channel, but it's like I'm not some big shot streamer, so I would say join the Discord server mainly to chat, not to get notifications. Okay, last thing. Here's one last thing that I wanted to show you. Right now, I have my editor Helix configured to use my LSP. So if I do hx health HTML, it will tell me, yeah, the language server that you're using is super, which is the name of my templating thing. So if I change my language config and I disable the thing where I assign super as the LSP for HTML and I run health, by default, Helix wants to use VS Code HTML language server, which is a copy of the HTML language server extracted from Visual Studio Code, as the name implies. You can find, like, there's a package that contains this guy plus a bunch of other language servers copied from VS Code, okay? Now, watch this. Watch how bad this thing is. You would not be able to believe it. So let me delete this body here. Well, the contents of body. So if I save it, it has a very opinionated way of adding new lines, but and indenting, because it decides to separate head body from HTML and keep all these tags at the same level. So it doesn't indent head and body, it keeps them at the top level. Choices, fine. But here's where things get funky. Check this out. Check this out. Look at my pre-tag. It gets indented. This stupid fucking thing doesn't understand pre-tags. And a while ago, I was modifying a HTML file with some code examples in there. And I basically blasted them. I completely destroyed them. So... and I didn't notice because, you know, do you really expect that thing to be this bad? I didn't expect it to be this bad. So, I mean, I think it would be nice to get this thing to a point where it's good enough that we can go to the Helix project and say, please, guys, the thing that you guys are using right now is a disaster. Would you be interested in setting this one as the default? Let me know what you think. Oh man. Okay. That was it. Let me refix my editor. Funnily enough, my own broken LSP is still preferable to that thing, at least for me. Okay, this was it. I don't have anything else. Let me see if anybody is streaming that I should send you to. So Tej DV is doing exercises for his C course. He's writing a C course and he's designing exercises. Should I send people to some C development? I usually have this thing where I'm heavily biased towards people doing lower level programming. Like, I think there's already enough, you know, JavaScript development streams, with all due respect. Sorry, X2. Yeah, we got the LSP working. Like, the auto formatting semantics are pretty good. So you know what? I'm not gonna stream anybody. Sorry. And end of stream. So I'll see you all soon. Bye bye. Probably tomorrow. So if you're around here still. Bye bye.